Hey, Calculus. I'm talking about question number 4 on test 2 from the Gray book. Uh, part A says you were given a differential equation dy dx equals y minus y squared over x, and you're asked to show that y equals x over x plus c. You're asked to show that that is a general solution to this differential equation. Now, I realize that normally we would do a little bit of separation of variables to do that, but in this case what we want to do is we want to take y equals x over x plus c, and if I take his derivative, I should get this differential. Okay? So to take the derivative of this, I'm just going to take the derivative of the left side, which would be dy dx, equals, to take the derivative of the right side, I've got to use our old friend, the quotient rule. So to do that, I'm going to take the derivative of the top, which is 1, times the bottom, minus the derivative of the bottom, which is still 1, times the top, over the bottom squared. Alright, simplifying the top, I would just get c over x plus c squared. Alright, again, if I distributed the 1, which I don't really need to do, and subtracted the x's, that would just leave me with c on top. Now again, let it make sense that if this is where I'm at with my differential, and this is where I need to get to with my differential, obviously the letter c is not in this differential. So this c has to somehow disappear. Well, if we go back to the original equation, couldn't I solve for c and then replace that down here? So if I do that, I would get x plus c times y equals x, and then x plus c equals x over y, then c equals x over y minus x. So now I can replace all these c's with this expression right here, x over y minus x. So coming back up here, I would get dy over dx equals xy minus x over x plus x over y minus x squared. Well, in the denominator, I can see that these x's cancel, so I'm just left with dy over dx equals x over y minus x over x squared y squared. Because again, now that the x's cancel, I can just square both the numerator and denominator in this baby fraction. Now I've got a complex fraction here. Ooh, hello. Now I've got this complex fraction going on here. And so I have to get rid of that complex fraction. My LCD is y squared. So if I multiply through by y squared, I get dy over dx equals, let's see here, that would give me xy minus xy squared over x squared. And I think you can see that I could factor out the x's and then cancel them with one of the x's here, leaving me with dy over dx equals y minus y squared over x. And there we go. We've achieved that differential that we started with. Part B says write an equation of the particular solution that contains the point 1, 2 and find the value of dy dx at 0, 0 for this solution. Okay, so we've already established that the the general solution to this is y equals x over x plus c. And I'm told that 1, 2 is a solution to this general solution. Therefore, I need to be able to plug in 1 for x and 2 for y. So if I did that, I would get 2 equals 1 over 1 plus c. Solving for c, I would get c equals, and again, this is just algebra at this point, I believe I would get c equals negative a half. So now I can say that my general solution is or my particular solution is y equals x over x plus a half. But that's a complex fraction, so if I multiply everybody by 2, I get y equals 2x over 2x minus 1. And that's a mistake. That should be a minus 1 right there, or minus a half. Now the second part to this question says find dy dx at 0, 0. So for this solution, so I've got to use this equation since it's for this particular solution right here. So I first have to find dy dx, and if I do that, again, I got to use quotient rule. So derivative of the top times the bottom minus the derivative of the bottom times the top over the bottom squared. And so simplifying this, I get dy dx equals this 4x and this 4x would cancel, and I'd be left with negative 2 over 2x minus 1 squared. And now at the point 0, 0, well, again, I'm just going to plug 0 in for this x. So I get, I'm going to call it y prime at 0 equals negative 2 over negative 1 squared, which would be 1. Actually, I'll just write like that, which would give me negative 2. And that's the part B. Okay, part C says find the horizontal asymptote and the vertical asymptotes for that particular solution, which again was y equals 2x over 2x minus 1. This is pre-calc. The horizontal asymptote says since it's equal degree, the horizontal asymptote will be the ratio of the two leading coefficients, which will be y equals 1, and the vertical asymptote will be x equals, let's see, the denominator would give me a half. Okay, and the last part says find the graph of this guy on that slope field. And the reality is you can use the slope field, but you can also use your pre-calc skills to graph this guy out. I know from the previous problem that I've got a horizontal asymptote at 1. I've got a vertical asymptote at a half. And at 1, 2, if 1, 2 is a solution, I know that this point right here will have to be on there. And then just following those slope lines, though we know what this would look like. It would come in looking like this, wouldn't it? But we know from this equation right here to get a point on this side of the vertical asymptote, and for example, like my y-intercept, I know my y-intercept, if I plug in 0 for x, I'd get 0, 0. And so I would have, this would be the answer for D. Okay, that's question number 4.